Hey folks, today we're going to do the Uranium-238 decay worksheet. It's really long. I believe it's labeled 3A. Right? What we want to do is we want to start with U-238. Alright? So U-238, and this is number 92. Alright? So what we're going to do is we're going to trace it through all of these levels of decay. Alright? So if we take U-238, 92, and we decay it through alpha decay. Alpha's 4 and a 2. All right. What we get is 234, and we get 90, and so that's thorium. So what we're going to do is we're going to take that thorium, and now we're going to go through beta decay. So now we have beta decay, which is a -1 down here and a 0. It has virtually no mass. All right. So that means we still have 234 on top, but now we have a 91. And a 91 is Pa, which I think is palladium. But anyway, no, it's protactinium. Anyhow, it continues down. It goes through beta decay again. All right. So if we go through beta decay again, that means we're going to have 234. The top number doesn't change, but the bottom number goes up to 92, which is uranium again. All right. And it then goes through alpha decay. All right, now alpha decay is 4 and 2. And so that means I have 230, and that's 90, and again, that is thorium. But it's not the same isotope it was up here. That was 234, now we're down to 230. All right, so it just keeps changing. We go through alpha decay again, and that's another 4 and a 2. So that is 226 and 88. And number 88 is radium. So that goes through alpha decay, which is 4 and 2. So that's 222, and that's number 86, which is radon, which is Rn. And then that goes through alpha decay. And so we go to 218 and 84. Right? And that's polonium. All right, well, we're not done yet, so we have to keep going. All right, so we have 218, 18, and 84, and that's polonium, we said, right? And so what we're going to keep doing is we're going to go down, we're going to go through alpha decay again, which is 4 and 2, right? The concept here is that uranium is going through all of these different levels of decay. It just doesn't happen once, it happens many, many, many times, right? It keeps cascading. So now we're down to number 82, which is lead. But this isotope of lead is not stable, so it goes through beta decay. Beta decay is a 0 and a -1, so that is 214, and that's 83. 83 is bismuth. So now we go through beta decay again, so that's 214 and 84, and 84 is polonium. And this goes through alpha decay, which is 4 and 2. So that's 210 and 82. We're back to lead again. But again, this isotope of lead is not stable either. So it goes through beta decay again. So it's a 4 and a 2. So that's down to 206 and 80. Right, 206, did I do that right? Sorry, my bad. I didn't read what I was doing. I'm doing beta decay. That didn't look right to me. Alright, so we do beta decay, and so that means that we have 210 and we have 83, and again that's bismuth. We go through beta decay again, and that's 210, and that's 84. And 84 is polonium. Now we go through alpha decay. This is our final decay, because finally we get to something that is stable, which is 206 and 82, which is lead. So we've gone through 14 different decays, which takes millions of years, but uranium-238 will eventually decay into lead. All right, so that's just to see how the whole thing works. All right, that's it, folks. We're done. Enjoy your day. See us if you have questions. Take care. Bye.